Hello students, welcome to today's lecture. So in this lecture, we are going to see about MQTT. So it is a machine to machine or Internet of Things connectivity protocol. It is a message queuing telemetry transport. So it was designed as an extremely lightweight protocol. Okay, so it is lightweight based on publish subscribe communication model. So it is useful for connections with remote locations where a small code footprint is required and a network bandwidth is at premium. Okay, so we are going to see this MQTT for the IoT application in detail. So message queuing telemetry transport. So it is an open source protocol for machine to machine and IoT connectivity. So the word telemetry, which means measuring and sending values or messages to the remote places by radio or other mechanism. So for example, it has been used in the sensors which is communicating to a broker through satellite link. So over occasional dial-up connections with the healthcare providers and also in the range of home automation and small devices scenarios. So it is also ideal for mobile applications because of its small size, low power usage, minimized data packets and efficient distribution of information to one or more receivers. So this IBM, so history is for MQTT is the IBM which first created the MQTT and is denoted as M2M PAHO project, which is a project of Eclipse. So a version of MQTT, that is version 3.1.1. So it has been accepted at 2014 as Oasis, that is an organization for the advancement of structured information standards. So the standard MQTT protocol is used for connectivity in M2M IoT communication. Okay. So the version for MQTT that is sensor networks version 1.2 and a non-TCP transmission control protocol and IP internet protocol networks such as ZigBee, which can use the MQTT sensor networks. So it is also a publish subscribe messaging protocols. So here the publish subscribing message protocols, the brokers which act as intermediators. So it enables the extension of MQTT protocol for wireless sensor networks and also the sensor and actuator devices and then with their specific network. So here we are going to see about the message interaction between machine to machine and IoT device using MQTT broker. So the MQTT broker which acts as the intermediate between the publishers and subscribers. Okay. So here the IBM conceptual framework which shows the MQTT applications for the communication management functions. Okay. So it shows the messages between messages interchange between M2M IoT objects, device objects, that is publisher and subscriber. So device objects, publishers and subscribers using a MQTT broker. So this is the MQTT broker where subscription match services, storage and forward services, message retention services, and then keeping message as an alive services and topics. Okay, so this is web objects which has MQTT Java, C or JavaScript library functions, and then SSR secure layer, transport secure layer, so and then TCP and then publishers. Okay, so this is the M2M IoT network. It also having that MQTT Java and then C or JavaScript. Okay, so this is M2M IoT objects and this is a web objects. So here the broker which acts as a intermediate between these two. Okay, so here the MQTT broker subscription. So MQTT broker subscription and then subscription match, store and forward and then message retention and keep messaging as a alive services. So device objects using MQTT Java or C or JavaScript library functions. So the objects which communicates using the connected devices through a network protocol such as ZigBee. So web objects which also uses MQTT library functions and communicate using IP network and then TLS, that is a transport layer security and then for subscribing and publishing APIs. So that is a publish subscriber APIs, which is known as application programming interface, and then transport security layer, and it is with the help of a socket secure socket layers, which are cryptographic protocols. Okay, so TLS and SSL are cryptographic protocols designed for providing communications security over a computer network. So like applications like web browsing, email, or instant messaging, or voice over IP. So the features of MQTT protocols with functions. Okay, so the library functions, it is also referred to as MQ, message queuing and telemetry transport broker. It is also referred as MQ. So that it functions as the server node capable of storing messages. So it is a node. Okay, so it is a node endpoints. So more number of endpoints can be stored from the messages from the publishers and forwarding them to the subscribing clients. Okay, so here it receives the topics from the publishers. Okay, so it examples such as information of ambient line condition, traffic density, and nearby parking space availability, and waste container status, so and so. So, and then it also performs a store and forward function. So here the publishers will keep the brokers as an intermediary one, and then after that response from the subscribers, the brokers will have the complete data. Okay, so it performs the store and forward functions, to store topic from publishers and forwards to subscribers. So the storing topics, so from the publishers, and it can be forwarded to the subscribers with the help of brokers. So here it receives subscriptions from the clients based on the topics, matches subscriptions and publications in order to route the messages to a right endpoints. So for which endpoint the particular message has to be forwarded or subscribed. Okay, so and also it recovers subscriptions on reconnect after a disconnection. If there is any disconnections between the network availability means, or if there is a particular node is disconnected from that particular topic which are subscribing means, so it recovers. Okay, so it automatically recovers unless the client explicitly disconnected. So once the client is disconnected, another resource will be taken in, that another resource will be updated. So as far as the client connectivity, so if there is any subscription disconnection means it can be recovered. Okay, so it acts as a broker between the subscribers and the publishers based on the topics. So it also finds client disconnection until disconnect message receives. So until the disconnect message receives from the client, so it keeps the client for the connection. Okay, it keeps the message alive. Okay, so till the explicit disconnection. So and auto it retains the last received messages. So it retains the received messages from the publishers for a new connected subscriber on the same topic. So if that topic is same means it also retains the last received messages. So when retain field is in the header set. Okay, so authentication by username and password in connect message. So under connect client security through SSL. So secured standard layer. So secure socket layer and transport secure layer security. Okay, so based on that authentication by username and password, in connecting message and client through SSL and TLS. So secure socket layer and transport layer security. Okay, so here the authentication is based on the username and password. So it keeps the messages in a message flow in a secured manner. Okay, so unauthorized data transfer is not possible in this type of transmission. So security consideration are same as constrained application protocol, and also web linking and restraint protocol. So controlled restraint protocol. So security considerations are same as constrained application protocol through web linking and constrained resource protocol. Okay, so security consideration are of same as constrained application protocol through web linking and constrained RESTful environment through source resource directory. So it also supports intelligent and business analytic server. Okay, so it accesses a business analytics through the data analytics process, and also other servers through MQTT server with the help of a gateway. So it is a communication device. So this is a data flow which is in MQTT method. Okay, so in this method, so here the MQTT broker which acts as an intermediate between the publishers and the subscribers. Okay, so here the publishing part is a topic about humidity, and the subscribing part is humidity. Okay, so here the humidity sensor which is from the input, that is IoT device, which is published to the MQTT broker, so where the subscription takes place. Okay, so here the online premise analytics and also cloud analytics takes parts. So the on-premise analytics is from the user application end, and also the data will be stored in the cloud. So far, in order to recover the data, in order to update the data. Okay, so here the MQTT clients, and then based on the publish subscriber model, MQTT clients are split into two groups: a sender, which is referred to as publisher. Okay, so a sender which is referred to as publisher in MQTT, and a consumer that is receives the data. So here these are the two consumers which is receives the data. Okay, so it is called as MQTT subscriber. So then the publisher and subscriber do not know anything about each other. Okay, here there is no communication for the or detail between the publisher and subscriber. So here the major part is done in the MQTT broker. So the publisher and subscriber do not know anything about each other. In fact, there is no direct contact. So there is not a contact with each other. The third component, so that is the MQTT broker. It acts as a traffic cop or a directing messages from publisher to any endpoints which acting as a subscriber. So the message topics, messages which makes their way from publisher through a broker to one or more subscribers. So it may be more than, so here that there is no there is a two subscribers. Okay, for example, for taking the humidity level, so here there are two subscribers. One is on-premise analytics and another one is a cloud analytics. So here the messages are transmitted through a broker to one or more subscribers. The subscriber may even added. Okay, so but the publisher, the sensor data, humidity sensor data will be the first thing, and then subscribers may be more than once. Okay, so every messages from publisher must include a topic. Okay, so MQTT topic is most important. So each level in a topic is delimited by forward slash. So it is represented by the forward slash. So every message as a public, you must include a topic to receive the published message. For example, we are receiving that humidity level. To receive the published message, the entity that consumes the message must subscribe. Okay, so it must be subscribed. So in order to receive the data, it must be subscribed to the same topic. So if the cloud analytics or on-premise analytics, so which subscribes to that particular MQTT broker means particular topic means, so it must be it must be displayed to that particular subscribers. So examples of a topic, it is building in a shop floor temperature. So that is delimited by the forward slash. A temperature location field. So for example, is having field 1 and row 10 means, so it will be subscribed to that particular topic. So it MQTT brokers and mappings for publishing the data are configured. Okay. So you can use another way. MQTT is used through Node-RED programming tool, which is performing the role of the subscriber. Node-RED takes incoming sensor data and process it and sends it to the visualization dashboards. So as the published messages from the base station continues, Node-RED dashboards are updated on the particular subscription. So we can connect to the organization through LP-WAN solutions. So the popularity of MQTT is that IoT architecture will also grow. Okay, so it is a more advantage one for it is a lightweight and also it is a easy method. Okay, so far we have seen about the publish subscribe model of MQTT through with the help of IoT communication.